Hello and welcome to another video, this time on Mechanics 2022 question 5, and it's a projectiles question. These questions, well, we're proving a general result, so this looks harder than the ones where you just get given like a speed and you just ask to find times or velocities or positions. This looks a bit more tricky, so let's just get on with it. I think pretty much everything is in the diagram here. Doesn't look like there's much, and also it's being fired to and from the same spot, so I can straight away write down what this is in terms of S. It's going to be 120 to the right and 0 up or down, which is nice. So what have I got? I've got U is U cos alpha, U sine alpha. Got A is 0 minus G, and that's U. I've got S is 120, 0. And I suppose I'll just put in a t in here and say t equals t, and try and find if I can find t with the x's and then carry it over to the y's. So okay, so let's use 120. Well, obviously s equals ut plus a half at squared is what I'm doing. And so I've got 120 equals ut cos alpha minus plus 0 if you like, so just ut cos alpha. And so that's nice. And then I've also got 0 equals ut sine alpha minus g over 2 t squared. Yes, I'm just applying s equals ut plus half at squared to the x and the y components. Looks like we want to get rid of t because this is all in terms of u, sine and cos. So let's make t equal 120 over u cos alpha. And then we get 0 equals u times by 120 over u cos alpha, sine alpha, minus g over 2 times by 120 over u cos alpha, t squared. Oh, sorry, that is t squared. I need to put in the, oh yeah, I've already put in the acceleration, so half acceleration, t squared. There we go. Okay, and what am I doing with this? I'm trying to put this in a form, oh yeah, which is to the left. Sorry, I'm slightly off put because somebody's trying to ring me. Apologies. So let me just have a good look at this. What's going to cancel there? Lots going to cancel. That cancels with that. Okay, and we've got then if we multiply here by, it looks like we should multiply by u squared cos squared alpha to me, because then it gets rid of that u squared cos squared alpha down there. What do we get? We get 120 over cos alpha, but we're timesing that by u squared times by 120. Now, and then we're going to get sine alpha cos alpha. And then over here we're going to get minus g over 2 times by 120 squared. Yeah, okay, cool. Now, if we now divide by 120, naturally, 0 equals u squared sine squared alpha, sine alpha cos alpha, minus, and then g divided by 2 times 120, I bet that's 588, I hope so. 9.8 divided by 2 times 120, 588. It's funny because I did this question earlier today and I swear I did it in a different way, but anyway, there's lots of ways of doing these things, there really is. Okay, there we go. 588 equals u squared sine alpha cos alpha as required. Cool. I wonder if I did the substitution in some of it. Oh yeah, I took the t out. That's right, I took the t out earlier, which would have made the 120 dividing by 120 at the end unnecessary. So maybe it was slightly better. Okay, so part B. Maximum height 10 meters above the ground. Okay, so that's going to occur at 1060. So, well, I guess we'll just go straight for it again. U is u cos alpha, u sine alpha. A is 0 minus g. S is 60, 10. And I just guess once again we'll write down t. Oh, well, actually we could write down the velocity, because we know that the vertical component will be 0 here. And from that we can see that using v squared equals u squared plus 2as, we can just say, well, okay, 0 is going to be u squared sine squared alpha plus 2 times by a times by s. And so 20g is going to be equal to u squared sine squared alpha. Okay, they got us to work this out, so I guess that's going to be useful. And I've got this here. This isn't obvious, but let's divide these equations. I mean, we're getting rid of u squared, which might look like the wrong thing to do. But if I call that one a and that one b, if I divide them, I actually end up with sine squared alpha over sine alpha. Oh, let's do b divided by a, actually. No, I'm a divided by b. Because this way, sure, we're going to get 20g over 588, but that's going to equal, the u squareds are going to cancel. Sine squared alpha divided by sine alpha is sine alpha, and then we're still going to divide by cos alpha. You know, basically you'll have sine squared alpha over sine alpha cos alpha, won't you? And you can write in the u squareds if you like, but they cancel. And so one of those cancels with that, and so you get 20g over 588 is tan alpha. Now, if you work out 20g over 588, I've got a feeling that it's a nice number. 20g divided by 588, because 588 was a multiple of g. Oh, we get a third, yeah? Now, if tan alpha equals a third, actually, that's really good news finding that, because I can just draw out my little triangle. I love it when I know one trig, you know, the value of a trig angle, because I know the value of them all then. It's always easy to do this Pythagoras trick and write down, okay, so now I know sine alpha is 1 over root 10 and cos alpha is 3 over root 10. So if I want to show that u was whatever it was, 1960 or something, I'm just going to now plug either of these in here, yeah? So 20g equals u squared times by 1/10, or in other words, u squared is 200g, and I think that is because g is 2g is 19.6, so 1960, just like it said, I think. Cool. In a refinement to the model, the effective air resistance is included. Motion of the wall from A to B is now modelled as a particle. This refined model is used to calculate a value of V. State which is greater, U or V, giving a reason for your answer. Ooh. Okay, right. So this will see, is this V the initial speed? So firstly, V is the initial speed. That's poor of an Excel choosing that letter. I would have gone for a different letter myself, but because V is obviously often final speed. But anyway, the refined model took air resistance into account, so you're going to have to chuck it with stronger values. So I think V should be larger. Yeah, V as you have to overcome the air resistance, so you've got to throw it faster. Let's show them we really understand it and throw it faster. Make it more realistic. Should we do consider the dimensions, take dimensions into account? Let's see what else you could have had for that one. Spin of the ball, size of the ball, dimensions, not a particle, variable acceleration, surface area of ball, humidity, humidity, allow wind resistance and rotational resistance, ignore any mention. So you could have had wind resistance rather than air resistance. There we go. So all sorts there, really. Okay, hope that was useful. Yeah, good luck in the exam. Bye-bye.